Just as we start, we want to do some thank yous. The very first one is to you for making this special crew event available to us. We are so excited.
Well, I was so pleased when I was offered the opportunity to reach out to anybody that I wanted to, and Barbara, you were first on my list. So I'm so excited that this worked out.
Well, that's wonderful. And John and Carol Heminger, your co-advisors, are here too. So we got a room full. So a couple of other quick things.
Excellent.
Laura and John at the Johnson Space Center were fabulous in terms of setting this up. And our IT guys here, we have Piazon and David, and back in the office, Jim and Chris, and they're the ones who are really making this happen for live stream. So we really appreciate their help. Tatiana in the Dean's office arranged to put it out on YouTube and live stream it. And then Melissa Sweet, our AirUCI project coordinator, of course, is always central to all these things. So I want to just make sure I do a quick thank you to them. So what we'd like to do is start with the questions, and I'm going to try to keep track of time, and you know how bad I am at that. But we'll try to, at 23 minutes, sort of wind the questions down so that at 24 or 24 and a half, we can say a proper goodbye and, not have you just cut off, which NASA says they will do. So let me start with the first question. So these questions are an amalgamation of questions from AirUCI and people around UCI. The first one is people who go into space describe seeing the Earth as a spiritual experience that alters their view of our world, our environment, and of humanity forever. Is that your experience? Actually, you want to be relaxing.
I had to switch positions because the speaker that I can hear you from is right here, and I wanted to get real close to it, and this was the only way I could secure myself. So I hope this doesn't distract you.
So did you hear the first question?
No.
I heard you guys singing, and I heard all the folks that helped put this together, which I'm very grateful to, Barb.
Yes. So I thought maybe you cut us off after you heard us singing. So the first question.
Wait.
Go ahead.
I was just going to tell you that I love the singing so much that you guys did that I reread the lyrics and rewatched the video because it brings me so much joy.
Well, we'll send you the revised last verse here by email. So the first question is people who go into space describe seeing the Earth from space as a spiritual experience that alters their view of the world and our environment and of humanity forever. Is that your experience?
I don't know that I would say that it altered it. It really just affirmed it for me. Looking at the Earth from this vantage point, it looks very delicate and vulnerable. This beautiful, plump planet in the middle of the vacuum and harshness of space. It's almost like an infant when it's swaddled in its blanket and so vulnerable. I think it just affirmed how important it is that we protect and take care of our environment.
And then a related question is, what's the most effective way of your sharing what you've learned and your deep appreciation of the value of our environment with people who never went to space or will not go to space, which is all of us?
Well, I think my words really fall short, but it's kind of the only gift I have. I'm not as good of a photographer, but I am living on board with some really fervent and fantastic photographers. And I think that the combination of the imagery that we're able to produce from our vantage point, along with our description of what we're seeing through those photographs are the best way to be able to convey to those who can't actually be here to see it themselves.
Great. So you can see the Earth below from the International Space Station. And do you notice anything that indicates air pollution and or extreme climate conditions?
You know, when you first look out the window, I don't know that it's as apparent or as obvious that it's pollution versus some other kind of natural obscurity like dust storms or just thin cloud coverage, but you can over time see degradation and depletion. And we have been taking photographs since the Apollo era. And those photographs from our Earth observation group have been very useful in terms of seeing the changes that have come over long periods of time to even short period of time. And so we can see, I don't know so much air pollution unless, you know, we're going over Southern California and having grown up there, knowing that the basin often collects smog, and having grown up with smog alerts, you know, I can identify that. But sometimes it's difficult unless you know the region really well and what they're prone to.
So how do you feel or measure time in the space station? Is there a special time zone for the space station?
Well, we have a rhythm up here because we have a timeline and a schedule, and so we're pretty much keeping pace with the day. We use Greenwich Mean Time, GMT, or UTC, Coordinated Universal Time, and gosh, I think it's about 9 hours ahead of you guys. I haven't done the math. I should have, but yeah, we just follow GMT time up here.
See.
And so right now it's about 8 o'clock to us, 8 p.m.
Okay. So if you were to become sick or injured while you were in space, what sort of medications or treatments are available?
Well, I just actually did an audit of our crew health rack, and we have about 13 of these packs that contain all sorts of pharmaceuticals as well as medical equipment. We have everything from diagnostics to minor surgery. We can administer IV, we can suture, we can do cardio treatments, but we're all trained to a certain level to be crew medical officers. But fortunately for us, we actually have Dr. Michael Barrett on our crew, and he is a physician. So oftentimes crews are blessed with having somebody that actually really knows what they're doing. So if we get injured or we get sick, there's always a way to talk to the ground and hook up with our flight surgeons that are on staff there or on console. And so if we had anything that was an emergency, we know how to handle it off of like a memorized, not memorized response, but we're trained for certain emergencies. But where we need input from a physician, if we don't have one on board, we call our flight surgeons on the ground.
So to skip ahead to one of the questions, then that's part of your astronaut training is to do some medical training. I mean, could you stitch people up?
Yes, we have some really good medical training, especially for those of us who didn't have that formally. It's a combination of field medical training where we actually go with we have folks that have background in medicine that take us to all the different medical centers in downtown Houston. There's quite an assortment. We've gone to trauma centers, burn units. We've gone to emergency rooms, and we actually get to work on patients like a medical student. But we get training on the ground prior to that on how to do some basic medical procedures like wound care, etc. And then we also get flight specific training on all of the equipment that we have on board. So, and we routinely draw our own blood and do the diagnostics on ourselves prior to any spacewalk, for instance. And so we get all of that training on the ground.
Very, very interesting. So how long is the training to be able to go to the International Space Station? And what was the hardest part of that training?
The training specific for your mission takes about 2 years, give or take. For someone like myself who flew on board the Soyuz, I do a lot of traveling to Russia, as well as to all the other countries that we have modules dedicated to their countries. We go to those countries to train on their modules and on their payload science, etc. And so it takes a lot of time to do all that, plus the traveling. But I would say the hardest part about it, and I know I'm not alone in this, is the time spent away from family. You're in training for about twice as long, if not 4 times as long as you are actually living on board the space station, and your family is often left behind, and you're talking to them remotely well before you ever get to the International Space Station. So I would say that time away from family is probably the hardest part about our training.
So the next question is, I'm fascinated, not me personally, this was the person asking the question, by NASA's efforts to understand the biological effects of extended spaceflight. Are there studies currently using mammals or cell cultures possible in space, and how does this happen in space?
Yeah, so we ourselves are human subjects, so we do a lot of human research studies on board. We also do research using rodents, and I understand that I'm not a biology expert, but I understand that mice are a very close analog in many ways to humans, and so we're able to study the effects of spaceflight, microgravity, certain conditions, and pharmaceuticals, treatments on mice, and be able to say something about, how well we'll be able to fare long duration missions, not just to the International Space Station, but to the moon and Mars and beyond. And so it's all in an effort to understand how the body adapts to microgravity, as well as taking out, the gravity component from many processes that depend on that, or are a function of that on the ground, and to see how well, or just to see what effect taking gravity away from the system will help to us to understand better.
So a related question is, what sorts of effects there are in your physical health when you go from Earth to space, or the other way around, space to Earth?
Yeah, the body is a really interesting thing, and it goes through a lot of adaptation in both directions. And so especially for someone coming from Houston, when you get to the space station, it's a much drier climate than we're used to back in the humidity of Houston. And so when you come to a dry environment like this, your body is probably spending about 2 weeks to a month just adapting to that. You're thirsty all the time, your throat's dry, the other thing is that we have this fluid shift, and you might notice my face is a little fuller than it normally is, and we all experience that to a certain degree. This fluid shifting, that when you're walking around on the ground on Earth, your fluid is distributed mostly in the lower parts of your body, but when we are in space, everything is floating, including the fluids inside your body, your organs. And so your face starts to show a little bit more how much fluids in your whole body that you wouldn't notice otherwise. Those are just some of the things that come to mind. But of course, when we go back home to Earth, you notice the lack of gravity, and how much you rely on. Oh, and that's one of my, that's Sunny right there. Speaking of microgravity. So you, in microgravity, we we suffer bone loss, muscle loss, those sorts of things if we don't work out. And so we exercise every single day while we're up here to help counter the effects of microgravity. And when we get back home, once we're through this phase of your vestibular system, trying to understand what you just did to it, it's a matter of reconditioning your body to now live and work in a 1G environment when for 6 months you were floating around effortlessly. So I don't know if that was a long-winded answer. I hope I scratched the itch of that question.
Yeah, you certainly did. Thank you. So were you able to view the total solar eclipse on April 8th? And if so, what did it look like from the International Space Station? Could you see the shadow on Earth?
Yes, we did. It was a huge event up here, and we saw the shadow. That's all we saw was the shadow of the eclipse, because the way that we're oriented in space, most of our windows, if not the majority of our windows, are looking down at the Earth, and we didn't have any to look at the sun. But the effect that it had on the surface of the Earth was phenomenal enough. It was this beautiful black eerie shadow, and we took several pictures of it. And we were all in the cupola watching it, and we had about 3 different orbits where we could see it, but one of the orbits we went right over the shadow, and we could make out some land features, but it was pretty dark, and it was very eerie to watch it come and pass underneath us, or we passed over it, and to watch it in our trail. So it was a very fascinating and fun event while we were up here.
Interesting. This spring, there was a period of high solar activity that resulted in northern lights being visible relatively far south. For example, Southern California, we could see them. Was there anything visible from the International Space Station during these periods of high solar activity?
Well, first of all, I can't believe you guys saw in Southern California, but unfortunately, no, we couldn't see them because of the period of time that this solar event happened. We were in what's called a high beta, a high angle of the sun, to the point where it doesn't really set in our orbit, and so it was daylight, and we're actually going through a period of high beta right now, and so it's basically like you're in the northern part of the world where the sun doesn't set, and so we weren't able to watch these gorgeous auroras. We just kept hearing about them, and it was torment, because when we do get to see auroras from up here, it is one of the most spectacular sights that we experience when we look out the cupola. And what I love about it is that it's like I'm watching ionization, from my own, the comfort of my own window. But it's unlike on the ground where it's 2-dimensional and it looks like this beautiful green, blue, red smear. Up here, it actually has depth to it. And so it's 3-dimensional, and it dances, and it's just gorgeous.
Wow. So becoming an astronaut is often seen as a lofty, impossible goal. Obviously not for you, especially for women. What steps did you take in your academic and career journey to get where you are, literally and figuratively, on the International Space Station as an astronaut? And how did your training as a scientist impact your training and career as an astronaut?
Well, when I decided that I wanted to be an astronaut, I really didn't know how I was going to become one. And it was really just a hope and dream that I had. And it coincided with a lot of things that I was interested in. And I was at the time, I was 16 years old when I decided I want to be an astronaut. I was also very interested in chemistry in high school and decided to major in that, not knowing if that was the path that I should take or not, or if it would lead me to being an astronaut. And then when I started my undergraduate career, when I met you, Barbara, I was I was still, I knew that I wanted to be an astronaut, but I wasn't exactly sure if any of the activities that I was doing was getting me there. And I would ask people. I'd get advice from others that said I needed to go into the military, but I wasn't interested in going into the military. And I had others that said that I needed to study astrophysics, but I wasn't interested in astrophysics. And so I just kept pursuing the things that I really enjoyed. And I was also an athlete, and I liked being a part of teams and everything like that. So I guess what I'm saying is I worked, I kept pursuing the things that I really enjoyed about the things I was studying. And as a result, it led me here. And I think if you talk to any of us that have made it into the astronaut corps, we all have a different story of how we got there. But I think one thing that is common amongst all of us is that whatever we did prior to becoming an astronaut, we really enjoyed it. And when you really enjoy what you do, it really brings out the best in you. And that's exactly what NASA wants, and what you need in order to be an astronaut is to work hard. And in fact, everybody here that's on board works super hard. And the environment that we're in here demands a lot of you, and at times when you're least expecting it. And it's really cool to watch everybody come together and solve problems, and to rise to any occasion that presents itself here on board. I feel like, did I answer your question?
Yes, wonderfully. So keeping an eye on the time here, because we know how precise NASA is, although they let us start early, which is wonderful. They said that we'd have 25 minutes. And so there are a lot more questions here. But they said they would just cut us off summarily. And I don't want them doing that without us thanking you. So I'm going to ask everybody here to put up a big cheer and thank you, and then we'll go back to the questions. And then if they cut us off, that's the way it is. Okay? Okay.
Well, it's absolutely my pleasure. I wish we had more time. I know that we are going to be coming up on a handover between satellites, and that'll cause a little bit of a gap. But it's so it's rare that I get a chance to talk to everybody back home. And I consider UC Irvine and AirUCI a home. And so it's absolutely my pleasure.
That's great. So would you have time for one more question if we don't get cut off?
Absolutely.
Yes. Okay. So question is, what are the current science objectives at the International Space Station? And are you involved in any of the scientific experiments on board? And if so, what's the coolest one you've performed?
Yeah, so our science objectives are multifold, and everything from biological sciences to human research to physical sciences, Earth observations. We do technology demonstrations, and especially since our Artemis program relies on some of the work that we do here on board the International Space Station to answer some of the questions that we will need to have answers for, or answer some of the questions that we have as we pursue going to the moon and beyond. And so the objectives are to understand the microgravity environment, the space environment, to understand the long-term and short-term effects on the human body, to understand materials and how they behave, and then to explore the microgravity environment, and in the absence of gravity, how do things behave, like fire? How do we make a better spacecraft? How do we make a safer environment on board? We need to understand how things behave in a combustion chamber in order to implement better materials, better fire safety, and all of these things, of course, are transferred to the ground and into the systems that we have on the ground to help make us safer just on Earth. Some of the science that I'm involved in range from being a subject to being an operator. Like I said, we're all subjects for human research, and so we donate many bodily fluids to the effort of understanding how bodies react and adapt. And so anything from blood to urine to the other things, as well as testing our vision. It's known that there's been some interesting phenomena with eyesight, and so we do a whole complement of very sophisticated studies on the eye. Those are just some of the examples, but we also do we operate other science on board. And one of the coolest things I've done is as a biofabrication study where they're 3D printing biological tissues. And when I first arrived on station in this facility, they were printing cardiac tissue. And we sent those samples back to the ground, and there's been a lot of praise and success for the work that they've done. But they're actually printing human tissue, and it has a host of benefits, not just for space, in order to understand whether we could actually reproduce tissues needed for, say, injuries or later on, well, for the ground, sorry, I keep saying the ground, but Earth. So transplants, it could be used as a means for transplants when transplants are not available. And that's long term, but that's really the hope and goal of those kinds of studies. But one of the coolest ones I'm looking forward to is one that I would actually do on a spacewalk. It's called microorganisms, and it's been described lovingly as giving the station a COVID test. But in my spacesuit, I would go out with a canister full of sample swabs and basically swab around areas that could have some human contact from our suits or vents from inside the station to outboard. And so we're going to look at the results and see if there's any kind of bacteria or anything that survives in the harshness of space. So I think that's pretty cool.
It is cool. Very cool. So as long as they're letting us continue to go, if you're willing, what's your favorite thing about the International Space Station? And what's the your least favorite thing?
My least favorite thing, I'll start with that, is I was just Sunny and I were just talking about this morning. I just finished up a series of a 24-hour urine collection, and I don't mean to bring up anything awkward, but I just want you all to think about, the next time you use the bathroom, what you would do with out gravity assisting you. And so imagine us up here having to collect urine without losing any of it. And it's a very tedious operation. It takes a lot of focus. And if you count the number of times that you go to the bathroom in one day, that's how many times we have to collect our urine. So it's I would say not one of my favorite things on board, but I know it's a necessary thing. But one of the coolest things is, and I'm not kidding about this, I mean, looking out the window is definitely top notch. And this is the only place you're going to see these kinds of views of our planet. And I would rank it up there, but right next to that is being a part of this incredible team. And our team is not just the 9 of us that are on board right now, which we are a pretty good team. And I really enjoy this aspect of living on board. But when you think about how expansive our team is on the ground, we have Houston and we have Huntsville, we have Munich, Scuba, Moscow. These are our control centers, and we have hundreds of people in the front rooms, in the back rooms, and in the back of the back rooms, all working on a daily basis, not just to help keep the space station running and keeping us safe, but also doing the science. And then beyond that, we have everybody that is working, to design experiments to be on board. And it's just the vehicles that we have coming up to the space station. There's a whole community of folks that are working to understand how to make space travel better and more comfortable and more reliable. And we have 3 vehicles on board this space station that are examples of that, and the host of people behind that. It's just an incredible privilege to not only be able to live here and work, but to be a member of that huge global team. And I think it rivals the view out the cupola.
Wow. So there were questions about what a typical day looks like on the space station, and also what a typical day might look like when you're earthbound, not in the space station. Is there such a thing as a typical day?
Yeah, well, we try to have typical days, but sometimes they get thwarted. But the way that the day up here is designed, Monday through Friday, assuming that we're not having to work the weekend for any purpose, but we wake up and just like everybody else, we get about an hour and a half of waking up, getting dressed, having your breakfast, that kind of thing. And then we have a meeting around the world called the Daily Planning Conference. We have one in the morning and one in the evening. And this is where we talk to all the control centers on the ground and to basically tag up with everybody to see if there's any changes to the plan. And then we just get started. All of us have tasks throughout the day. I'd show you our timeline. I just don't think the camera's going to resolve the view very well, but we each have a band and we work from 7 to 7 basically, and we have tasks